Okay, so today we are introducing another undefined term to our list of things that we talk about. So far, for our undefined terms, we have points, lines, planes, and then we had segments and rays. Today we are adding our last undefined term, which is an angle. So, angles are made up of two rays coming off of the same endpoint. Angles can pretty much be of any size. One of the things we're going to be talking about today is measuring them. But before we get to measuring them, we're going to talk about naming them. There are a lot of different ways to name an angle. One option, and this option is a little more limited. Let's say the endpoint that these two rays have in common is the endpoint A. That is one way that we can name the angle, is we can name it by its endpoint. And we use angle symbol followed by that point. This way of naming, though, is limited. The point of naming things is that I can name it and then you look at the picture and you can tell exactly what it's talking about. This naming system is limited because of the fact that it is possible to have more than just two rays coming off the same endpoint. Note I'm drawing it on the board. Do not draw it when I write it on the active board. I don't think I emphasized that. Now, if I had that third ray coming off of this endpoint, and I say I'm talking about angle A, it's hard to tell which angle I'm talking about because technically now there's three angles in this picture. There's that one. There's this one. And then there's the big one. So, the moment I have another ray coming off of this endpoint, I can no longer use a single letter name. So this only works if it's the only angle with A as an endpoint. That endpoint is also known as the vertex. I know, lots of parentheses there. A common endpoint is known as the vertex of the angle. The two rays themselves are called the sides of the angle. This form of naming is great with simpler pictures. But most of the time when we go to naming our angles, we're going to name them a different way. So, other ways that we can name this angle. Sometimes inside of an angle, there will be a small little number right next to the vertex. It will be between the two sides of that specific angle. This case, I'm putting a 1. Now, you have to pay close attention to if there is a degree symbol next to it. Y'all know what I'm talking about when I say degree symbol? Same type of thing that you put on temperatures, degrees. Angles are measured in degrees. So, when it comes to our angles, if they don't have a degree symbol next to that little number, that is another possible name for the angle. You have to do an angle symbol, which looks like an angle, again. And then you can put that number. This way tends to pop up a decent chunk, but this way also has limitations. This way has limitations in the sense that it will only work if the two rays, if the two sides of the angle have nothing else between them. if I had, again, go back to that idea before of if I have another ray going through, now I have no way of naming that angle 1. I can call the top one by a number. I can call the bottom one by a number, but the big one, I have no way of naming it that way. So the most common way that you are going to see angles named is using a 3-letter name. This 3-letter name requires that there be a point on each side of the angle. So a point on each of the rays. And you name it by the 3 points where the vertex, the pointy part, has to be the middle letter. So this would be angle BAC or angle CAB. Which letter goes first and which letter goes last does not matter as long as one of each of those letters is on each ray, but the middle letter has to be the vertex. Naming angles is one of the things that is crucial that we get down because of the fact that throughout all of geometry, we are going to be talking about angles. And you have to be able to differentiate which angle we're talking about by me giving you the name. So, today there's going to be a lot of emphasis on angle names. So, give all names for the indicated angle. So, first picture I've got is this picture here. Options for naming. Single letter name. Which letter is the vertex of that angle? Let's start there.
Q.
Q. Q is our vertex. Is there one angle with a vertex Q or multiple angles with a vertex Q? Just one. And in that case, then we can use the single letter name and call it angle Q. That's one option. Now, going down our list of names from up here, the next option is if there is a number. Is there a number inside that angle? No, so I move on. The next option is 3-letter name. Yep, I've got points on each of the rays. Which letter has to be where?
Q in the middle.
Q in the middle. So PQR. Is there another 3-letter name? RQP. Okay. Those are all the names for that specific angle. Problem B. Can I do a single letter name?
Yes.
Yes, what letter is a vertex?
B.
And that's the only one coming off of B, so I can call it angle B. Can I call it by a number?
Yes.
Angle
4.
4. 3 letters?
Yes.
Yes. What order?
A, B, C.
Is that the only option?
No, you can also do C, E.
Key thing, and I probably should have written this up here. Vertex in the middle. Okay, last picture is a more complicated picture. It is focusing in on the angle that has the shaded part to it. I see the shading is here, so I'm talking this angle. Can I do a single letter name for that angle?
No.
No, because its vertex is R, and there's lots of angles that could be called R. So we can't do that. Can I call it by a number?
Yes.
Angle, which one is it?
1.
1. Can I call it by 3 letters?
Yes.
What order?
S, R, P, or P, R, C.
SRP
Yeah. S,
or PRS. Now, I'll be honest with you. Beyond this section, I'm probably not going to ask for multiple names of the same angle. It gets a little redundant to do that. We're doing that right now because knowing angle names is just a really important thing, and it's also something that trips people up. Most of the time, though, when you look at the diagrams, you are going to have to be able to identify all of the angles in a picture. This one wants you to use the diagram and name the 3 different angles that are in the picture. Just one name each is fine. Unless it specifically specifies it wants all names, it just wants one name for each angle. Do you see the 3 angles in this picture? Oftentimes people miss one of them. This is the first one. What's its name? Angle PQR. Don't forget the angle symbol. 3-letter names, you have to make sure you have their symbology that goes with them because there's a lot of things that get named by 3 letters. Planes, for example. Okay, so angle PQR. That's that one. How about the smaller one here? RQS. The last angle is the big angle of the picture. PQS. Now, just a little bit of vocabulary, nothing that's too crazy, and honestly, I could probably give you these terms and you could guess what they mean. One of the things we'll talk about at times is we'll talk about points that are located either between the sides of the angles. Imagine I have an angle like this. I'll have a point right there that's between the 2 sides, or outside of the 2 sides of the angle. Here's my angle. There's the point. These are called either interior points or exterior points. We're not going to do anything crazy with interior and exterior points, but these terms will pop up in definitions. There will be times where it will describe if you have an angle and a ray having the same endpoint going through an interior point in that angle, you can do blah, 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 blah. So, that's why I just need to bring up this idea. Okay, other things that we're going to be working with today is we're going to be working with angle measure. So, we want to find the measure of this shaded angle and name that angle with its appropriate name. So, a little bit similar to what we were doing. Slight shift. Okay, shaded angle is right here. Do you notice inside of it, it's got a number? But do you notice there's a degree symbol on the number? That is the angle's measurement. The moment you see a degree symbol, that is a measurement, not a name. So the measurement of this angle is 123 degrees. What is the name of that angle? Gabe says it's CDE. Do you agree with him? Yeah. Now, notationally, if we want to say angle CDE is 123 degrees, it's not quite like writing this. There's just a small switch that I have to do to this because it's kind of like talking about segments. Remember when we talked about segments? With the bar above it, that's the segment's name. Without the bar above it, that's the segment's measurement. Angles have notation for name and notation for measurement too. Its name looks like this. You want to talk about its measurement? You just put a little m in front of it. It means the measure of angle CDE. Okay. This one here. Shaded angle is that one. What's the name of it? Someone other than Gabe who's answered most of my questions. Not all of them, but most of them. BDC. So, that is angle BDC, and its measurement is? 38 degrees. You'll figure that one out when you figure that out. Okay. Now, we are doing the one more page here, so just as an FYI. Lots of things with angles, but the last thing that's on this page is actually nothing too scary. The key thing about this, though, is making sure you're finding the right angle. Because as we get more complicated with pictures, knowing which angle we're talking about, like I said, is very important. So, I'm just asking you to put a little X inside of the angle that it's referencing. The first one talks about angle STR. Now, angles can live inside of shapes. So, being able to tell where STR is important. First thing, you need to recognize where those three letters are. Now, you don't have to put the little dots on them. You just have to at least mentally recognize that's S, that's T, that's R. S, T, and R are the corners of a triangle. The question is, which corner is angle STR? Is it the top one? Is it the bottom left? Or is it the bottom right? It is the bottom right. If you are ever struggling with finding an angle, start by finding its vertex and then draw over the segments that go towards the letters of the first and last part of the name. This is angle STR. Angle UTV. Which letter's the vertex? T. Draw the lines going towards U and towards V, if that helps. That one goes towards U, that one goes towards V. Angle UTV is, therefore, this one. Do the last two on your own. Try them out on your own.
What were you doing yesterday? In Mr. Hagen's class?
Exactly.
You were. What? I don't know.
Okay, I believe I got to everyone, and yes, it's that one and that one. What time? Okay. Now here's the thing. I know y'all have seen angles before. So, when we talk about our angles, and we talk about measuring them, most of that should be a little bit familiar. One of the things we do with our angles is we classify them by their measurement. Y'all have heard these terms before. An angle that's smaller than 90 degrees. Do you remember what that's called? Acute. It's an acute angle. You could have a 45-degree angle, but it's not guaranteed to be 45. A 90-degree angle is known as a right angle. Greater than 90? Obtuse. Angle exactly 180. Close. Close.
Level.
It's a straight angle. So you're close an idea. Flat, straight is the technical term. So, classifying and measuring angles is another important key. Now, sometimes I'm going to give you the picture of the protractor. Other times, you got to use your own protractor. So we're going to use this diagram to find the measure of these angles, and then we're going to classify them as well. So, the first one it asks about is the measure of angle GHK. First and foremost, H is the vertex going towards G, going towards K. Now, if I look at this angle, can I tell if it's acute, obtuse, right, or straight? It appears to be obtuse. You would be correct on that if you said it was obtuse. You could tell without actually measuring it unless it's really, really close to 90 and doesn't have a 90-degree symbol in it. Remember, the 90-degree symbol is the little box in the corner. That's what guarantees a 90-degree angle. But if I draw something that looks like a 90-degree angle, it could be a little bit bigger, it could be a little bit smaller. It's hard to tell. Okay, so I'm looking for the measure of angle GHK. Now, to make a protractor work, first thing they have to do is you want to align one of the rays of the protractor up with the bottom and the vertex with the center. Vertex is on center, one of the rays is on the bottom. So this one's already aligned that way. Now from there, that tells you which scale you need to look at on the numbers, because there are two different scales depending on which side you align with. This one's pointing over here. Now when you're trying to measure something, the two things I see here is 0 and 180. Do you start counting at zeros or do you start counting at hundreds or 180? You start at zeros. So whichever one it's pointing to 0 is where you want to start. So this one's starting 0 at the outside measurement. So now I look at the other ray and say, okay, what number's at the outside measurement?
125.
Between 120 and 130, exactly in the middle, is 125 degrees. If you're ever not sure if you looked at the right scale, go back to, did you say it was acute or obtuse, and does that match? Is a 125 degree angle obtuse? Yes. That means you probably looked at the right scale. Measure angle LHJ. Okay. Did they line up H in the middle? Yep. Here's L. Here's J. Did they line up one side of the angle with the bottom of the protractor? Yes. This one specifically. Now, again, the scales, one starts at 180, the other one starts at 0. When you are measuring things, which number do you start at, 0 or 180? 0. So which scale am I using, the outside or the inside one? Which one starts at 0? Inside. So we're looking at the inside scale. The inside scale stops this one at 90. This is a 90-degree angle. What's its classification then? Yep, thank you. Next one's JHK. H is lined up in the middle perfectly. The other two letters are K and J. So here's my angle. Did they line up with the bottom like they were supposed to? Yes, they did. They lined up with the bottom going to the right. My scales start at 0 and 180. Which one do I want to start at, 0 or 180? 0. So inside or outside? Inside scale. What number is it pointing at? 55. So the measure of angle JHK is equal to 55 degrees. Now, pretty sure I heard Jackson say it was an acute angle. Does it look acute? Does 55 match with being acute? Beautiful. Sometimes they're going to do certain things a little different. Like MHK. MHK, the vertex is lined up where it needs to be. That always has to happen. But if I'm talking about this angle, did they line it up with the bottom like they were supposed to? No. Now, if you had the physical protractor to pick up, I would just pick it up and reposition it. But if you don't have the protractor to pick up, you could still figure out the measurement. Neither of your scales are starting at 0. So, pick a scale to work with. Do you want to work with the outside scale or the inside scale? It doesn't matter. You just got to make a choice. Outside. It's the first one I heard. On the outside scales, this is at 35 degrees, and this one's at 125 degrees. Now, traditionally, when you're looking at the scale, you're going from 0 to wherever it starts to figure out its measurement. But can you figure out the measurement that goes from 35 to 125?
90.
How'd you get 90?
I guess. Or like, I'm guessing.
Fair.
Like,
It looks like a 90?
yeah.
Is that how you're guessing?
Yeah.
Okay, be careful of that. You're right that it's 90,
Sweet.
but essentially we're just looking for the difference. Technically, we did the same thing when we started at 0 too, but the difference between 0 and any number is the number. The difference between 35 and 125, you could find by doing 125 minus 35. You can subtract the two numbers if it doesn't start at 0. If it's a 90-degree angle, it is a right angle. Okay. The last two follow the same option. I want to talk a little bit about one of these on the bottom. We're going to take a look at the middle one. The one that's named angle A. Now these ones are asking us to do the same thing. They want us to give the measurement and to classify it. Could you tell me its classification without measuring it?
Yeah.
It's acute. Now you can use the fact that it's an acute angle then to help you with its measurement and with which scale to use. Okay, to work with protractor. Middle thing has to go on the vertex. Kind of see where they cross right there? It's a little hard to see on screen. That goes on the vertex. One of these base lines goes along one of the rays. It doesn't matter which one. I'm going to zoom in obnoxiously for a second here. Protractor, vertex here, and then this bottom line is going along one of the rays. Once I have that lined up, I look at my scales again. This ray, again, it's pointing to either 0 or 180, but when we start counting at 0. The outside scale is the one that has the 0 on it, so I'm going to look at the outside scale. Is it easy to tell where it's pointing? Not when the numbers are so tiny. Sometimes you might need to make the segment longer. So I'm going to pull my protractor away and use it as a straight edge right now to just make one of my rays a little bit longer. It makes it a little easier to see what it's pointing at. So I just made that longer so I could see more easily. Once I've done that, I line it back up again. Vertex at the center point, one of the rays pointing to the side. Now I can see a little bit more easily where it is on the protractor. It's between 30 and 40, but is it smack dab between them?
No.
No.
37.
It's at 37. When degree measurements are so tiny, it's hard to see unless you really look closely. So as a result, sometimes you might be a tiny bit off. Generally, when you're using a physical protractor, I give you a little bit of wiggle room on what number you could say. If you said 36, I wouldn't have held it against you. If you said 38, I wouldn't have held it against you. Because it's not perfect. But you want to be as close as possible. Generally, I give 1 degree of wiggle room. Okay. I've spoken far long enough today. Got about 10 minutes, which might not be a huge amount, but I promise you on these problems you can get some stuff done. You just need to get your book open soon, quickly, because it is a book assignment. By the way, I write the assignments on the backboard. You can always kind of look on what it is. You're on page 41. Day 1. Again, when you do your assignments, day 1, day 2, day 3, if I ever write that on there, they should be on separate pages. And please write day 1 or day 2, whatever it might be, on the top of the assignment so I know which one I'm looking at without having to look it up.